We have Bernardo today with us, and he's going to be talking to us about Paguro, Know Your Data Frame with Paguro, declarative and composable validation, and metadata using Polars. So yeah, off to you.
Thank you.
Yeah.
Thank you very much. Thank you for having me, and thank you for choosing to come to my talk. I'm very excited to be here. I'm very excited to present this software, which is called Paguro. I'm Bernardo Dionisi, and this is a project. Paguro is a project I've been working on for now several months, and it is for the past couple of hours. It has been an open source project that is based on the Python library. It's based on the query engine Polars, but it's mainly based on the Python API. Do you guys know Polars? Everybody knows Polars, and do you know? Have you used it a little bit? So you used like the expression API and everything. Okay. So Paguro is a data validation library. It has also other components to it, which I will mention, but I won't go into details. But I want to like show you what data validation is in Paguro. So this is the timeline for the talk. I'll start with a little bit of motivation. What is data validation? So everybody is on the same page what I'm talking about here. And I will be talking mainly about tabular data validation. And you probably can fit a lot of type of data into tabular data. But this talk focuses on tabular data. And I'll give you a basic example and a little sneak peek of the Paguro API. Then I'll step back a second and talk about the current frameworks and how people tend to do data validation in Python. And then I'll try to explain how I think Paguro is a bit different and how I hope it aligns a lot with the way that people use Polars. If there is time, I'll give you a little bit live demo. I've seen people do it, and it looked very scary. So I thought, why not? let's be scared. And then maybe a little show of the documentation and then the Q&A. So what is data validation? Data validation is just the process of making sure that the data is what you expect it to be. So you expect it to be accurate, reliable, and consistent. And in this context, there are two main branches of it, of the validating the schema of the data, which means the correctness of the columns, the data types, and the content, which can be local consistency, meaning that you're trying to verify that your entries are as expected, or a global consistency, a global view of the data, for example, distributions, or making sure that the data, the time series is not shifting. So why is it important? So just a quick search online, you can find reports that mention that organizations on average spend $30 million a year on data quality. This doesn't this translates of a lot of employee time. Like some reports say 27% of employees tend to spend it on fixing data issues. And but it's not just a matter of monetary cost. It's also a matter of what decision making. This data leads to maybe poor decision making, and it is going to be, if it's going to be used in models, may lead to flawed models and other type of challenges. So a very simple example: we have an expectation, maybe an order. We are an orders table, and we expected to have an ID and total amount. But reality comes, and maybe the data that was generated by a query or was by an LLM. Today, it may be the case that this is data generated through an LLM. But even just like transformations, right, on your pipeline. So you have some transformations, you may have some bugs that are not easily detectable, and the resulting table is not as you expect it to be. So how does Paguro handle these problems? What is the API that Paguro tries to introduce to handle this problem? This is what it looks like to validate a data frame or a table with Paguro. Basically, you have these two objects, like a valid frame and valid column, and these are two independent objects. I'll go a little bit more into details later on this. But basically, you can see as a Polars feeling, right? Like you have this expression looking like validators that you define. Once the data comes, you basically validate reality, and Paguro gives you a very nice terminal formatted output. And a lot of work went into creating this type of outputs, and this is built in Paguro. I forgot to mention, Paguro has only one dependency, which is Polars, one required dependency. So, and there are two extra dependencies, but they have very little impact. They're only a couple of methods. They're used for a couple of methods. And also this reporting table is an SVG generated with Paguro. And it is not a screenshot of the terminal. So these are reports that you can generate in SVG and HTML and send, automatically send to you when data doesn't meet expectations. But before telling you a little bit more about Paguro, I want to take a step back and look at what the approaches are in Python for data validation. And I want to classify them in two groups, like a model-based approach and a scope-based approach. So a model-based approach, if you're familiar with Pydantic, and Pydantic basically has a workflow that derives from like Python data classes, in which you basically define a model and its components and as a class, right? You inherit from a base class, which injects some methods and some attributes into your class, and then you have all your attributes. And this type of framework has been adopted by others, like very popular one is Pandera, to kind of feed the tabular data format, because this, as you can see, this attribute level, it would be the entry level, it would be your single row, it wouldn't be the entire vector, the entire column vector. So what people have adapted it to be is that your attribute now represents your full column, doesn't represent only your entry, and your checks are at the column level, right? And then you have your methods that are column level checks. So here I also put a side of, it doesn't need to be, a model-based approach doesn't need to be a class. It can be also an object, a dictionary. And when I think about a model-based approach, I think about like this relatively flat structure. In a class, there is inheritance, but in a dictionary, there is this relatively flat structure in which you define what your data should look like. So what are the benefits and drawbacks? But, well, you have a nice tidy declarations for your data. You gain, with a class, you gain some degree of static typing, some degree in the DataFrame world. In the Pydantic world, you gain full degree of static typing, but in the at least for the attributes. In a DataFrame world, you get some degree of static typing, and but of course, when you're doing transformations in your data, this can add complexity, right? You need to like declare all these models for maybe different steps of your transformations. The scope-based approach takes a little bit of difference, and I think great expectations to my understanding would fall a lot on this. It does have a more declarative way, but great expectation that your workflow puts it as you start from a scope, and then basically you have all these methods in the library, and these methods basically define what are the validation steps that the library is going to take to tell you whether your data is as you expect it to be. This, of course, from a library maintainer perspective, has a lot of flexibility because you can define a lot of methods, right? You can define any methods that you can think of, and in the background, you do your checks, and then you report them back to the user. However, when you use this kind of libraries, there is a bit of like, you need to keep track of all the methods, right? There may be a lot of methods. Some may not be fitting your needs as well. And you don't get the static typing on your target data, right? Then just for completeness here, what happens is that then you get reality, and your model or your scope tells you that your data is not or is as you expect it to be. So what is the expressive approach that I'm trying to introduce here is basically I took out the box around these shapes, and basically introducing very independent validators that can be combined in a tree, right? So, and I'll tell you in a second why I think a tree is a powerful way to express validations. So what are these independent validators that Paguro has? As we saw before, there are column validators. So this can be used separately from a valid frame. You get a valid column validator. You can specify your column, or you can pass a selector. So a Polar selector basically tells you just select all the columns of this data type, right? And then you can pass a selector, and all the checks that you have in your validator will be applied to all the columns that the selector specified. So the checks here are just Polar's expressions. So this being just Polar's expression makes it very lightweight, very fast, and we don't look at the data. We don't have to manipulate any data beside filters, which Polars gives us a lot of speed for. Then you can combine these columns into the valid frame. And here, I did not make a mistake. You can combine valid frames into valid frames. This is where the tree structure comes from, ends up being. Why would you do that, right? Why would you put another valid frame inside a valid frame inside a valid frame? Because inside the valid frame, there is also a parameter called transform, and you can apply transformations to your data that are deferred to the moment in which you call the validation. So deferring means that it is not even a lazy frame. It's a step before a lazy frame. It's sort of a Polar's expression, but it's detached to any source of data. So once you can define this prior to having any data, and then when it's passed, the transformation will be applied, and the validation will also tell you whether the data is correct or not. So this transformation can be, for example, you want to check whether a group is different from another statistically. This is hypothesis testing, and you can easily do that by defining a transformation that outputs a lazy frame, and you will get your answer back. The third validator. It's valid relation. So we go from column to frame to cross frame. So this basically is going to validate. You can put all the valid frames that you want, and the checks in this case are going to be lazy frames. Are going to be callables to lazy frame, callables that return lazy frames, and then you can define referential integrity between your data frames. This is going to be a cross-table validator. And I'll show you an example in a bit. So these all have their validate method in it, and they're independent to each other, and then you get this report. This is the same report as before for ease of exposition. Otherwise I would put multiple parts. But now I want to introduce another object, which kind of makes this possible, right? Because now I showed you that there are validators, and they are kind of like Polars expressions. A Polar expression is basically just an object that contains operation between one or multiple columns, right? A validator here is an object that contains predicates. How do we evaluate this object? We need a context to evaluate it in, right? Just as Polar expressions have their context, you have with columns, select, filter. So here I introduce the validate context in the Paguro dataset, in which basically we can just pass your validators, and if your validation passes, you can just chain all the operations that you get from a data frame. So a dataset is not a data frame, and does not inherit from a data frame, but composes from a data frame. And it contains all the methods that a data frame has, but it will not work if you pass a data set into a join of a data frame. It will not work. If you pass a data frame into a join of a data set, it will work. This is because Polars does not allow inheritance, but actually we wouldn't want inheritance in this case, because we also intercept your call to the method to validate the object automatically, and I'll tell you that in the next slide. But before that, I want to tell you also that you can also, if you import Paguro, you need to import Paguro, because validate is going to be it's going to be attached here to your Polars data frame only if you import Paguro, but you can just call validate in your Polar data frame. You don't even have to use your a data set. And this will return a data frame if your validation passes, and it's going to raise a validation error if it doesn't pass. So why would you want to use that set over data frame if you can do that directly in data frame? Well, since Polars doesn't have the validate context, you do get a Polars data frame back, but it's not statically typed, right? The Polars doesn't know what comes out of the validate. Actually, you can also, you don't even need to use a validator. You can just use a Polar expression. So you import Paguro, you do validate, you use a Polar expression like this, and this is going to validate and raise a validation error. What is the difference between this and just doing filter, right? What is the difference between calling validate and just calling filter? Well, if you put multiple Polars expression, a filter will return you one table with the predicates that are satisfied. If you call validate, it will raise a validation error if they're not satisfied with the columns that are separate. So if there are co-occurring errors, you don't have a single table to go through and see which rows have co-occurring errors. You have separate data frames that show you the information. So is this all that the dataset object has to offer? I don't think so, because there is also another method called with validation that is going to attach validators to your dataset. This is not going to validate. Actually, it will validate if you set the configuration, the global configuration, to automatically validate, but it's going to attach the validators to your dataset. So whenever you call a method, let's say you call a select, and you configure, you set up the global configuration to have auto-validation, this is going to raise an error if your select lands into a data frame, returns a data frame that is not that does not satisfy your validators. So I want to give you a live demo, and let's see, there is time. In the live demo, I cannot show you this object, right? And now you understand what these validators are, and I'm not going to repeat what I showed you before. I'm going to show you something a little different, another way of doing things, because this is not this expressive API is not can also be used can also be used in a model-based approach. And this is also included in Paguro, and let's do it. And I'll show you the model-based approach and what you gain from Paguro from having also a model. So I split the model and the validation. Oh, yeah. Let's see. Actually, do you know how to do this? No, control process I just tried.
Control scrolling.
Okay. No, it's not working. I did not. Okay, sorry. No, I tried that. It's not working. That appearance.
At the bottom. Keep going.
Oh, increase font size, sorry. All right. Control Shift. Okay, thank you. Okay, let's do it. Let's import Paguro. What do I want to show you? Okay, let's do. I'm just going to define a very simple data. Let's call this data set. Okay. So you have a data set, which is basically a container for a data frame, and you have this column right now, which is, one is just an integer column, one is a struct. You'll understand in a second why I choose to also use a struct, because otherwise all the rest is going to be flat. This is going to show you the. So how do you extract? How do you work with a data frame, right? Let's import Polars here. And now I'm going to just select. I'm going to select the inner inside the data frame just to show you what typically, like when you do that, you do go like this and you do field. No, this. You have to print here. Okay, you select field. This is the typical way, right? So you can see that a data set has like a select context. It also has all the methods Polars, but let's do something different. Let's do so. So let's do a model-based approach with Paguro. And here I called a method called collect model print, and I call this collect because it collects the schema, and it returns a module that represents your schema in in the way that you import a base model from Paguro. You define your columns like you define in other libraries, and then you can use this model. So in this case, it's DataFrame model. We have column A, which doesn't have any validators, any checks yet, because we didn't look at there are options, but we didn't look at the data. But here it's very free. The only check here is that nulls are not allowed, but you can allow nulls. But in this case, we don't have any nulls. But you have your dataset model, right? Now, what do we do with this dataset model? Typically in libraries, you have to take this model and you call validate, but there is no validate here, because here with this model, you pass it to a with model context, which is different from with validation, because with the validation just define the validation. With model is going to define both the validation as well as the model for your data. So now that you have you define the model, this validation passed, right? Because the model passed, the data respect. If the data did not, the data here is 0. So for example, here, if we say this is greater than or equal than 2, this is not going to pass, right? It's going to raise an error because the value was 1. But let's let it pass and say this is our data model. Now our data set respects our constraints. What happens now with your model set? So now you have a scope. You already can imagine that has the attributes which are in the instance of your data. This is different from many. These are not on the model. These are in the instance of your data. You have a scope in which you can just this is statically typed, right? So you can do that, and basically you can do yes, select, and then you can select your column like this. This is why people don't like live coding, I guess. There is also, this is going to select the column. And now for the struct, you can imagine where we're going here. You have an outer, and then you have an inner. And this is all auto-completed, right? And then you have your expression for the struct, which is already computed as this expression here. But this is going to be statically typed, so your type checker will find errors if you make any. And you can already see where this goes. So here, when you start Paguro, you only start Polars and Polars runtime, and you get all these nice things. So just to walk you, just an overview. These are the 3 ways to construct validators. So with valid column, and valid column you can actually use valid column struct to just specify struct and all the other data types. You can call it, or you have a get attribute in which you basically pass your column name. And in the examples, you can find, just to show you, just for completeness for before, like a relation validation error, you define your relations like this. The orders table and customer ID must be included. All of the customer's IDs must be in the customer table. And then you get a validation error that is nicely formatted. And that's it.
We can take a couple of questions if anyone has anything to ask. Yeah, let me just.
Thank you, great talk. I was wondering, it's a little bit meta, but I think data frames occupy this part in the data ecosystem where you're reading something and you're okay with it maybe not having a set schema and breaking, and you can figure that out yourself later, versus what this ends up looking like is writing almost a SQL schema, right? And a bunch of other validation logic. What do you think the role for this would be in a data engineering workflow, right? Where the data is changing in the back end a lot and you're reading it and you expect it to break a little bit versus if you're reading a table. And second, it's somewhat related. I think types go a long way in a lot of languages to do validation, like so a uint 64 versus an int64 would probably catch the -1, but maybe you would still want to catch overflow. Have you looked at kind of those type of approaches of validating data as more type-based ones as opposed to predicates, which I imagine get pretty expensive?
So yeah, sorry. Okay, let me answer your questions in order. So for the first question, you're completely right. And this is why I was unhappy how data validation tools for DataFrame look like. They looked a lot like defining schemas for SQL, like for SQL tables. And that's why I think a model-based approach is good for like, the input data, and then at the end of your pipeline, you have like, maybe you want to define a schema for your user, and this is where these live, this type of validation live. At the beginning and at the end, maybe. And in the middle, you have all these transformations. You're OK with how things look like. And that is why I think an expressive API, having these independent things and having a context to say validate, or being able to call validate an ending point of your pipeline without like on the go. It's valuable because maybe something breaks and you don't know what it's breaking, right? You may, if you have a data set that you say, I want this column to never be null, and maybe you have a join in the middle of the pipeline that creates null values for your column, and at the point you may need to go back and look into the pipeline. This way, you have one single validator that ended up being injected in there, and you can just find your problem. So this is, I think, the nice part of having this expressive object and independent object is compared to like having to define a model. At the end, I show you the model base because you get like the static typing niceties. But I think, I personally think that the model base is nice for only very small portion of the pipeline of the data frame life, as you imagine, as you said. For data types, yeah, of course, I kind of skimmed over and say they are Polars expressions, but the base is that you can pass a data type, which is going to validate the data type. Of course, it's going to you can pass a required. These are not Polars expressions. These are on your schema. So this is going to validate prior to validating the data, so you don't have to read the data for the schema validation. So
a quick follow-up on that. From what I understand, in Polars lazy frames, you have to specify a schema because that's how the query engine, I guess.
The lazy frame, when you read the data, the schema is defined. Yeah.
Yeah, and that does a little bit of validation because you just get parse failures. And
you don't have to specify it yourself. Like you can read a Parquet file with a schema that you may not.
I see.
So you just read a Parquet file. If you don't define the schema is defined by the reader.
I see. And in the join example that you gave, like an optional type, kind of like in Rust pure, right? If you join two tables in Polars Rust, everything is assumed to be optional, and you can't add two optionals without, I guess, grokking the types. Is that something that's possible here as well? Because I think null is a weird thing.
Yeah. So like changing the types of the column, you mean? So for join is this is gonna, if you have a validator that defines that the column must be of that type, if you join and the type changes, this is gonna raise because you defined your type. You can be very flexible with your type. You can define an integer type that is going to be all the integers that Polars offers, so up to 128. But you can also be more strict and say, I want an int 8. So if the things change, this is going to race.
So I suppose the naive way to validate data frames is to just have like a Python script that looks at each column and run some asserts. How much easier could my life be if I stopped doing that and used this kind of tool? Like, where are the big efficiencies in terms of time?
Oh, I think, so personally, I think like this is going to be very, so when you, I'll give you an example. When you do that, when you do specify all your predicates, when you say your assertion, like you're basically in a Polars pipeline, you have your data pipeline, and at some point maybe you say, you specify a predicate expression, you filter your data and say, oh, your data shouldn't contain any negatives, right? And you have your assertion that says this data does contain negatives. What happens there is that you have to define the column, right? You have to define the column. So you say pl.call, and you have your string there. And then maybe you have that in multiple spots of your script, of your program. And this way, you define the column once at the validator level, and all your checks are going to be independent, like they're going to be Polars expression, but they're not going to be bound to a specific column. So once you have your validator here, you just specify your column once, and also your predicates once, and then you reuse the validator across your pipeline. Or if you like attach it to a data set, you actually have it live there. But I think it makes, personally, I think the ease of use and makes it worthwhile to give it a try and tell me what you think.
We have time for 2 more questions.
I know this is for Polars. Is there an analogous tool for pandas?
So you can pass a pandas data frame here, but it's going to use Polars in the backend. So there are many tools for data frame validations. I don't think there is any with this type of API. I'm going to step ahead. I've been working on something for more general tooling, but this for now, that something is going to be a subset of what is possible here. Because this now has a lot of, what?
Like this, the Polars will allow for a lot more parallelization?
No, in terms of features. So yeah, that also, but that's on the backend side. That's not on me, right? But for example, this Polars have very nice selectors, selector syntax. Other tools are not yet to the level of the syntax. They're going to be there, but having also, I gave you also the example of specifying a column. You can also just specify a selector with predicates attached to it that are not attached to a column, so you don't even need to use a string at all sometimes. But yeah, no. So you can pass a data frame, pandas data frame, but the return types will be related to Polars. They won't be pandas.